Piston engine has a 4-stroke cycle, which include the inlet, compression, combustion or power stroke, and exhaust. All of this process is happening in the same compartment and happening series, so one after the other. This means that only quarter of the engine operation each cylinder is producing the power. The jet engine has absolutely the same process inside, so it has an inlet, compression, combustion and exhaust. But all of this process is happening continuously, so they are not intermediate. Jet engine has the same process inside, but all of this process is happening continuously, which means that our engine is continuously suck the air inside of the engine. It's continuously compressing the air, it's continuously provide combustion, and it's continuously replaced exhaust gases away from internal part. Comparing to the piston engine with intermediate process, the jet engine with continuously process inside requires completely different mechanism and generally consists from the few basic elements. Inlet duct, where air is preparing for the proper entering into the compressor. Compressor, the part where air will be compressed inside before the combustion chamber. Combustion chamber, where we will add the fuel and burning this fuel to producing the power inside. Turbine section, which will steal part of this energy for the operation of compressor and the different gearboxes, and exhaust nozzle, which will properly replace the exhaust gases away from the jet engine and producing the thrust. Inlet duct is providing their functions via special geometrical shape. On almost all modern jet aircraft, inlet duct has a divergent shape, which means that in the front part of the inlet duct it has a smaller diameter comparing to the aft part, where it has a bigger diameter. This shape is worked like the backside of the venturi tube, where the static pressure is increased and velocity is decreased. Increasing of the static pressure at front of the compressor is really important for the stability of the core part of the jet engine. The worst condition for the jet engine from the view of the inlet duct is the aircraft which is flying on a low speed with a high angle of attack. In this case, air will entering into the engine with some angle relative to the engine axle, and relative velocity of this air will be also low. In this case, static pressure at front of the compressor will decrease, which can significantly decrease the performance of the engine and the increasing tendency for compressor stall. Some old generation, the jet engine has a specific vents which is located around of the inlet duct. They become open when aircraft is flying at the high angle of attack and providing more air and a higher static pressure at front of the compressor, which is decrease the tendency of compressor stall. From the view of engineering, compressor is the most complicated part of the jet engine. Compressor is the part of the engine which located after the inlet duct and compressing the air, which is increase the pressure of this air, and as a side effect also increasing the temperature at front of the combustion chamber. The main parameters of any compressor which is affecting on the performance of the engine is the airflow, or how much of the air compressor can provide for the combustion chamber, which are normally measuring in kilograms per minute or kilograms per second, and compression ratio, which is difference between pressure outlet of the compressor and inlet of the compressor. The basic principle of the compression ratio is the same like with the piston engine. The higher compression ratio, the higher efficiency of our engine, which means higher power and lower fuel consumption. But as with the piston engine, we have a limit. If compression ratio of the piston engine will be too high, we will catch the detonation and our engine may take significant damage. If compression ratio of the jet engine will be too high, we will not catch the detonation and we will not catch any damage of our engine. But this engine will be super huge and massive, because we have only one way how we can increasing the compression ratio. If the compression ratio of the piston engine will be too high, we may catch the detonation and our engine will take the significant damage. In case of the compression ratio of the jet engine will be too high, we will not take any detonation or damage of our engine, but this engine will be huge and massive, because we have only one way how we can increasing the compression ratio in the jet engine. or we're using more stages of the compressor, or we're making these stages bigger. Yeah, theoretically we can make this engine with a super high compression ratio, and it will provide for us super high efficiency. And yeah, theoretically we can make an engine with a super high compression ratio which will have a super high efficiency. But this engine will be too big and too messy for any aircraft. And in case if we will install this engine on an aircraft, it will decrease the total efficiency of this aircraft.